I'd like to talk a little bit about the program, the idea of what it means to program, what's involved, what it is to be in this role, and how people try to draw parallels to other disciplines, how people also look at the role from some of the wrong perspectives. For example, we use the word production and productivity a lot, but these are words that we associate with machines, not with people. So I want to look a little bit about what makes things tick. Quite literally. That's the only visually bad pun. I think that I have to thank Nick for setting such a low baseline in humour that almost anything that I say will seem witty and sophisticated. Thank you, Nick. Right, so I'm kind of on a vague campaign. It's not a concerted campaign, but it is a campaign to reclaim the word program. Because a number of people say, well, you know, programmer, it sounds really low level. I want to be called a developer. Yeah, sure, I use the word developer. But it's just like programmer, it makes it sound like a bit of code. It's like, well, okay, so first of all, is it just that? And secondly, what's wrong with just that, even if it were? So first of all, we need to kind of understand. So we're going to go out and look at the vast wisdom of the Oxford English Dictionary, the one who writes computer programs. This is surprisingly accurate. Okay? You know, you can't fault it for that. Let's be really, really clear. If you look up the word developer, the first entry is not good. Okay, developer. Well, let me think, that would be real estate developer. Do you really want to be associated with that mob? One who writes computer programs. And you say, oh yeah, but it's just more than writing computer programs. Well, hang on, what's writing involve? There's this idea that writing is not the act, this mistaken idea, writing is the act of typing. No, that would be one who types computer programs. The very act of writing involves a remarkable amount. One of the things that I do one of the things I do generally is I write. I write technical books, I also write non-technical stuff. It turns out that in order to write, it's not just a matter of putting one word after the other. It turns out you actually have to have something to write about. And you would like to find out that it is the right thing. So you go and do things like research. And then when you have written it, you check what you have written. It turns out that it is not the act of typing. It turns out the act of typing is a tiny, tiny In order to write, you need to do an immense amount of work. So writing is not a bad thing. It actually has an implication of a far larger thing. But while we're at it, here's another definition. A person who prepares and tests programs for devices. Oh, okay. Guess what? It turns out that testing was in your job role. A lot of people did not know this. They said, no, it's not my job. I program. We have people called testers to test. It's like, no, that's not their job. Their job is to test the system. Your job is to test the code. You may end up testing the system, but the idea is that you don't sit there and go, oh, well, you know, I'm done. You know, are you done? What do you mean by done? That compiles. You're good. Even better if you're using a dynamic language. Oh, I don't even worry about compiling. Hell, just have it. So, you know, and I used to, there's a chap my wife used to work with. She used to work at a company that did produce devices. And they had all the kinds of engineers there. They had the mechanicals, they had the electricals, they had the software guys. And she came home one day and said, you know, you'd have really had a popper tester today. Because he writes, this guy's writing device drivers, and one of the testers kind of came into him really irate. Now remember, these are not just testers, they're system testers. They're trying to test that the whole thing fits together. They really don't want to have to deal with minor, easily found bugs. He says, your code is so full of bugs. And the tester says, yeah, but it's not my job. You know, it compiled, so I gave it to you guys test it. It's just like, oh, okay, so there's clearly a lack of understanding as to what's involved in this thing. However, I think the one definition we can all agree on is this one. This one's from Urban Dictionary. An organism capable of turning caffeine into code. There is very little argument with that. I mean, I know that there are programmers who don't drink coffee. I eye them with a slight Slight suspicion. But I'm a tolerant type. Normally they're ex-caffeine drinkers. You know, they've got that kind of slightly worthy feel about them. But, you know, they've been there, which is okay. I'm fine with that. So, the word program is not a bad word. It's a surprisingly precise word. And it also informed my use in when I put together 97 Things Every Programmer Should Know, which is in Japanese translation, by the way. It's also translated into Czech, Chinese, twice, traditional and simplified, Korean and Russian. I have to say, I love having books where I can't actually read them. It's very nice. But I'm going to say that the Japanese one wins by just a little bit over the Korean one in terms of production qualities. Those two are the best. They really are quite wonderful. The paper quality, the fact they even use a dust cover, they look great. I have no idea what to say, but they look great. And there's an element here about the craft, about the attention to detail, that I think is also quite nice. And this book is a crowdsourced book. Basically, I've got 73 people in there. They've contributed 97 items on what every programmer should know. And it is a subset. I was very specific about choosing the word programmer. I did have a chat with O'Reilly about the vocabulary. They said, well, maybe software developer. And I said, well, yes, if you like spending syllables like that. But on the other hand, programmer is surprisingly unambiguous. But there's a point here about all of this, how it all fits together. And I put this in the preface, so I kind of pulled it out, translated it back into English. There is an art, craft, and science to programming that extends far beyond the programmer. The act of programming marries the discrete world of computers with the fluid world of human affairs. There is this idea that one of the things that makes programming both interesting and challenging is the fact that it is not just about the discrete world of computers, the idea of the crisp, uncompromising domain of bits and bytes for constructed types. It is also about bridging it between these kind of negotiated and uncertain truths. That is actually one of the things that makes it what it is. It is not because it is one domain, it is because it actually stands between two domains. And that is, as I say, it's both that's where the pleasure and the tears come from. So, looked at from this perspective, I think it's interesting when we try to understand the act of programming and the role of programmers and their inclinations from other perspectives. Now, Paul Graham, who's well known as in the Lisp community, he wrote this essay a while back and based a book on it called Hackers and Painters. And I think it highlights a pitfall that we are all prone to when it comes to trying to draw parallels. Parallels are very useful, metaphors are very useful, but they are not, let's put it this way, metaphor is not identity. Metaphor is simply a suggestion about how to interpret some stuff. It is not actually the territory. It's not even a very good map. But he makes this, he draws this parallel. Hacking is in kind of the classic programming tradition. Hacking and painting have a lot in common. I remember reading this going like, well, okay, I'm surprised. I will admit that I don't really paint. Occasionally I draw, but certainly art is not a foreign world from my perspective. And I was very surprised by this. I mean, sure, there's relationships to many kinds of art, but painting specifically. And he says, in fact, of all the different types of people I've known, hackers and painters are among the most alike. Okay, I'm going to say one thing. I think he needs to get out more. I find that there are lots of people who are very similar to other kinds of people, and lots of people who are different. Sometimes we can stereotype successfully, and sometimes we fail miserably. But I'm interested in why he thinks this is the case. What hackers and painters both have in common is they're both makers. Oh, well, nobody else makes. It turns out, makers have a lot in common. That's a different suggestion. I don't know why he's picking on painters. Actually, I do. He does painting. But that's the thing, is we're often very, very drawn to our own subjectivity. If you're going to try and make an objective assessment, you need to try to check yourself at the door. Yes, indeed, I'm going to say hackers and other forms of maker are indeed similar. There is this idea of making stuff, tinkering with stuff, and there is a kind of continuum that goes from pure code to code and hardware, whether people are hacking around Arduinos trying to mess about with their fridge, or whether they are going a little bit further into Raspberry Pi territory, or whether they are trying to do something with Lego, and then they throw in a little bit of electrical or programming stuff in there as well, all the way through to constructing sheds and all the rest of it. There is a continuum here that does make sense. I think the maker parallel is valid, but singling painters out, I don't think it makes sense. And he said, as he then properly acknowledges, along with composers, architects and writers, what hackers and painters are trying to do is make good things. Again, I don't see why he's picking on painters. I don't understand what the parallel that is so specific here. And I'm going to come back to writers, because I'm going to say that actually if we're going to pick on a group of people, writers are probably much, much closer. So let's look at a painting. It's a nice painting. Starry Night, Vincent van Gogh, 1889. Painted in Provence while he was in an asylum. One of his masterpieces, great piece of work. And again, we fall into this trap sometimes of saying things that don't actually make sense, because perhaps we're not looking at something deeply enough. Don Wells makes some very good points when he looks at agile processes and the like. But one thing stuck out and caught my eye. He said, he was talking about models in this particular piece, and the idea of models, and the idea that sometimes people use this idea of model as a blueprint, and this kind of thing. I think this is a very unhealthy way of looking at things. Your software does have a blueprint. It's called the code. It is a precise specification of how the whole thing should fit together and work. The code is not a manufactured item. The source code is not the thing that is executed on the machine. It is a thing that informs what is going to be executed on the machine. It's not the same thing. The software, the blueprints for software already exist. That's the code. So what are we doing when we're modelling? Okay, he's trying to pull away from the blueprint perspective, and he says, no, we need to think of them. We need to think of them not as being this kind of precise and complete thing. You think they are suggestive. And he says, agile models are paintings, not photographs. You know, I'm going to disagree, because I do a bit of photography, and as I said, I don't do much painting, but I can certainly appreciate something. He's trying to say, and he actually makes this point, and I think it was in connection to this picture, that this is an approximation, it's a suggestion of what Vincent van Gogh is thinking. It's not precise. Actually, it is precise. Those stars, they look suggestive and random, like a child might have thrown them onto the page. Actually, their positioning on the canvas is precise. It is actually possible, and it has been done, to determine precisely what night Vincent van Gogh painted this, because of the position of the stars in the sky. There's no approximation of it. This is not fluffy. He's actually being remarkably precise. Although he is abstracting, he has not lost precision. So the idea of this as a model is not helpful. I'm also going to say that photography, when you photograph something, and in fact I've got some photographs of mine, in fact the opening slide was a photograph of mine, I've got some photographs of mine dotted throughout the slides. When you photograph, you choose what you're going to show and you choose what you're not going to show. You actually, it's not an arbitrary thing. People think that photographs are a perfect capture of reality, just as he's doing there. They're not a perfect capture of reality. For example, that picture of me, where are you? It doesn't make sense to have a person just standing on a stage, The whole point is there is a context missing. So it turns out that actually photographs may actually be better than paintings in this perspective. When you're looking at something, when you're abstracting something, you are choosing to remove detail. What he's trying to say, but fails by using the wrong artistic medium, is what I've said here. Agile models are not paintings. If anything, they are sketches. Now, a sketch is a deliberate, not just a cutting out of detail, it is a deliberate idea of glossing over and suggesting or holding back on certain kinds of detail, but still suggesting the presence of detail. That turns out to be important. You suggest the presence of form. So we've got to be really careful. If we're going to start talking about paintings, then perhaps we need to know a bit about paintings. But I'm going to say, let's not talk about paintings, because software development really is not an awful lot like painting at all. I don't want to say it's like something else, but if I'm going to pick anything, I'm going to say it's a bit like writing. One of the things I got really good at is photographing books. And I also write non-technical stuff. I write short fiction. Flash fiction mostly. I had published in New Scientist, Physical World, and a couple of other places, and won a couple of competitions, which has been nice. And one of the things I have learned is that writers have an awful lot in common with software developers, and they have an awful lot that is different. And by standing in a different domain, you can sometimes learn an awful lot about another one just by standing in a different domain. You get a different perspective. One of the first things I'm going to say is that writers work with composition. They work with symbols, they work with tools, they are trying to convey meaning. They're not trying to convey meaning in an abstract kind of fluffy sense, they're trying to do it fairly precisely. The way they convey meaning is quantifiable on the page. You can go and count the number of words, for example. You can look at the range of vocabulary, you can look at the effect that it has. So there's an awful lot there in terms of questions of style. It turns out an awful lot about, you can learn most style guides, it turns out, that are for writing, apply at least 50% to software development. In fact, I saw a really good talk recently by Peter Hilton, where he drew some great parallels from advice by writers that translates directly into coding, particularly the naming of variables and things. In picking on George Orwell's Politics of the English Language, he was able to go through that and say, actually, pretty much all of this applies to coding, the very act of coding. And I find that, his observation is certainly true, because I've used quotes from various style guides for years to influence how I think about, and influence others about how to think about the program, the very act of coding, naming, composition, style. And although there is a visual arrangement in code, it turns out that it is the basis of meaning that we're most interested in, is the choice of words. So there's a good correspondence there. There's also working to constraints. Writers work to particular constraints, not merely a size of a canvas, but there are questions of genre and shaping and form and expectation, translation into other forms, either translation by language or translation to screen or whatever. And then there's the bit where the writers are really different. One of the things I find fascinating is people often say, oh, software development types, they're kind of a little more introverted than other people. Well, on average, there might be an element of truth to that, but quite frankly, unless you've met writers, you really don't know what introverts are. If you put it this way, how many software systems do you work on where you are the only software developer? Are you the programmer? It turns out normally you are in a team. Writers don't really work in teams. Yeah, they do for TV scripts, and screenwriting they probably work in teams a lot more. But regular writing, no, we talk about individual authors. It's not the same with programmers. There's a very big difference. We spend half our time trying to figure out how to talk to each other. We spend a lot of time doing, writers don't even bother. So there is a really big difference in certain places, and I think that's also informative. So I'm going to say, if we're going to pick on something, then let's talk about writers. In terms of all the people that are makers and create things, then it's things that have meaning that are perhaps the closest, things where people are manipulating a textual form that are the closest. The idea of composition and editing and re-editing and changing is not unknown in other making disciplines, but it is rampant in both writing and software development. There's even a quote, writing is rewriting. And when you look at that point of view from software development, then that really kind of informs, yeah, actually this is the case. We don't just let the image stand, we change it. But of course, don't confuse the map and the territory. There's a semantic gap, a very big semantic gap. These are at best suggestions, and they draw parallels, and you can borrow things, but you have to remember what to leave behind. Sometimes you just have to look at it head on. And I really like this quote from the Clue Train Manifesto, a book called the Clue Train Manifesto, where trying to evaluate what is it that people in technology kind of get a buzz out of? What is it that kind of floats their boat? People in high tech take pride in their work. They are individuals who see the details of the things they produce in the light of the trials and triumphs they experience while creating products. Well, already it's a very eloquent description of the joys and the pains. But in the courage of creation, emphasis on creation, they find a place to hang their individuality. Programmers and technotypes appreciate elegant, spare code and the occasional well-turned architectural hack. I like this. It's a lot more descriptive than many of the parallels people try to draw, because it actually tries to say, right, this is it, head on. People like something that's elegant, but they also appreciate kind of a really good hack every now and then. It's got to be well turned though. It can't just be a hack. It's got to be, ooh, that's kind of, ooh, dirty but good. You know, there's, And any language or set of guidelines that prevents you from doing that immediately invites you to do that. So, you know, there's an ingenuity there. There's a sort of there is an intellectual side of it which is particularly strongly appreciated. Now, of course, what we're talking about, I've talked about a very program-centric view, and obviously, see, when we talk about the evaluation of software, what we mean by the software, you know, it has to ultimately come out that somebody's going to use it. And we often focus on, you know, we abbreviated it down. Usability is so important, it's gone down to 2 letters. All that said, I think it's kind of cute, but don't look too closely at the Greek interpretation of UX or whatever. UX, I think it's not a bad term in terms of the spelling is a bit weak. User experience, but there we go. It does highlight the point that there is an experience to be evaluated. What is that experience of the software? But at the same time, I do feel a little bit uncomfortable with the term UX engineer or UX designer. That feels very uncomfortable. I am going to design your experience. That's kind of creepy and dystopian. So, whilst I'm happy with somebody saying they specialise in UX, they specialise in it, but to be a UX designer is just like, yeah, that's just the wrong set of words you've pulled together there. But we can generalise this as well, because I want to go back to the code-centric perspective. What is the experience of the programmer? So I think as we often forget that programs are people. Bizarrely enough, this is one of the most recent discoveries. Programs are human too, and therefore they have exactly the same strengths and weaknesses and cognitive biases and strengths as other people. So therefore, it turns out that understanding human beings gives you a massive insight into understanding programs. Anyway, the 21st century is just ramping ahead in terms of its discoveries, but what this tells us is that there is, what is it that somebody does? What is it that the programmer is experiencing? Well, they're certainly experiencing tools, but actually they're experiencing code. So I recently coined this phrase, PX, program experience. What's the program experience of the code? By the way, for anybody who specialises in security, feel free to generalise this to security experience. That should, you know, that works quite nicely. Yes, I'm an SX designer. I mean, you should get a lot of calls for that. You might get a few emails blocked though. What is the programmer experience? So there's this idea that goes back. I've dealt with the patternless community for a long time. I've read a couple of books on design patterns. One of the influential figures is Dick Gabriel within this community. He wrote this rather nice book, Patterns of Software, which, curiously enough, is not actually just about patterns. It's mostly about software development and various ideas. It's a little bit autobiographical in his point of view. Rather nice book, sadly out of print. You can get the PDF from his site. And just as an aside, he's a writer. He's also a poet, so he makes some parallels to poetry, which is kind of interesting. But he also makes a really interesting point about PX. Habitability. This is, for me, one of the most important and overlooked aspects of the architecture metaphor. When we talk about architecture in software, it draws to mind a lot of very useful and constructive perspectives. It focuses on something that is structural. It gives you the sense of that there is an architectural style. There is a set of decisions that characterise this system as being this system as opposed to any other system. It also tells you that there are many architectural styles, and therefore the idea that there is one true architecture that is good is nonsense. That there are many schools and thoughts, there's appropriateness of matching one architectural style to a particular problem domain, and the very same solution that is good for one thing may turn out to be horrifically bad for another, even when well executed. So this is all wrapped up in the architecture metaphor, as is the idea of function and purpose. So, for example, I have met a number of developers and indeed a number of architects who have gone on to say at various points, oh, well, we don't really need to worry about what the system does to have a good architecture. It doesn't make any difference what the requirements are. It's just like, that doesn't make any sense. And again, the architecture metaphor rescues us from this fallacy. Because clearly, if you are designing an auditorium, and your goal is to have people come in and to have recitals and performances and so on, you're going to end up with a completely different approach and completely different design model, particularly in the outer building structure, to the suggestion that you might be designing a school. The purpose of a school is quite different. Hospitals also have different structural constraints. Residential homes have different construction constraints, and so on and so on. In other words, the purpose will ultimately constrain and encourage certain architectural styles. Again, this is wrapped up in the architecture metaphor. But the one that I don't see focused on often enough, although people do focus on it, perhaps not often enough, is the idea that in architecture you're creating a space in which people live and work. And therefore you must ask the question, what is the quality of that experience of living and working somewhere? And we can say that for a building, we can say that for your home, you can say that for your office space. What's it like to be there? Is it a comfortable place? Does it have habitability? Habitability is the characteristic of source code that enables programmers and so on coming to the code later in its life to understand its construction and intentions and to change it comfortably and confidently. So there is a concept that we don't merely build structures, you actually live in them. And if you're spending your day inside a code base, then guess what? You're spending you're living in that code space. And you have to ask the question, is it livable? And habitability makes the place livable, like home. And this is what we want in software. Developers feel at home and can place their hands on any item without having to think deeply about where it is. In other words, that we are able to comfortably work within a space and second guess where things should be. In other words, there's no surprise when you sort of say, well, I don't know where that feature is implemented, but given everything that I've seen, it should logically be there. And lo and behold, it is. It's comfortable and it's easy to work with. And this idea of habitability, I think, forms a fundamental part of the programming experience. Or the lack of habitability does this. And this is the question. When somebody says, okay, you're going to need to make some changes here, and you think, oh, it's in that bit of code over there. I like that bit of code. The methods are all nice and short and well-named, and the classes are nicely factored, and there are tests, and, you kind of go in there and you don't feel that there's junk code or any noise like that. It feels comfortable to be there. And you think, yeah, I like this. And you'll cultivate it and you'll make sure that you are not the person that messes it up. Oh yeah, that used to be a really good part of the system until Kevlin started coding. You don't want to be that person. And they will be in the version control unless you spoofed somebody else's. But also, it's not just a case of backside preservation. You're also looking at this from the perspective of, I like doing this, why would I mess it up? I like working in this space. This is what, this is a certain pleasure to it. Or do you end up with a piece of code that is thousands upon thousands of miles long, that challenges the very idea of an event horizon, as it disappears into a black hole, it's sitting there going like, I have no idea what this code is doing. And you're sitting there, lost in a twisty little maze of code, and you don't know which way out to go, but you have to make a change. And I'm going to make a change here, but I don't know that it might mess up something else, so I'll tell you what, I'll copy and paste some code from somewhere else so that I know exactly what's going on here. And then I'll get out as quickly as possible, but which is the way out? I'm lost, help me, and that's it. You lose so many programmers in there. Oh yeah, we're going to send you into that subsystem. Nobody ever comes out of it. So this is kind of idea of habitability. It's like, what kind of place? And this is the problem. Code that is not habitable actually has an associated cost with it, not just the kind of little bit noise. Is that people's mindset, because it turns out, guess what, programmers are human, and they respond to an uncomfortable or an unpleasant environment in exactly the same way any other human being would respond to an uncomfortable or unpleasant environment. They don't like to be there, and they might either adopt an aggressive stance, a military stance. Okay, I've got these changes to do. I'm going to get in there, I'm going to hit it as hard as possible, I'm going to do as much damage, and then I'm going to get out as quickly as possible. Okay, we've got the helicopters inbound, do your damage. Chuck Norris all over again. And then you have the people who are just kind of like lost in there. These are lost souls forever wandering the brackets. So, yeah, habitability matters because it actually it influences your mindset, whether or not you feel a deep and profound sense of despair every time you go into the code, or whether or not, actually, this is good, it's rewarding. One of the most interesting polarizing experiences I had on this was a company I visited a few years ago where I was told, I was invited in by the architects for a week, and it was basically try and talk about the architecture as a whole, what they could do to regain control, so there's a lot of politics involved, and how they could, and there were a number of issues. I won't go into those issues. But one of the interesting issues that I was confronted with was they said, our developers, the two architects who contacted me said, well, these guys, you know, they're not really into programming. You know, they're real 9-to-5ers. You know, they just sort of come in, they do the code, and then they go home, and that's it. They're not really interested in programming as an art, as a craft, as a science, as a thing to really get you buzzing. They're not really into it. You know, you never these people hack it. What was interesting is when I turned up, I asked to meet them, and I asked each person, you know, went around just to get a sense of what else did other people do. What did they do at home? It turns out pretty much every single one of them was either teaching themselves a new programming language or contributing to an open source project. I remember thinking, I think they're testing me because they've given me a different group of programs to the ones they said they had. Because these people are like serious geeks. Okay, these people are seriously into their code. But then I realized, no, the problem is, and it became clear throughout the week, that what was happening is these people really were into programming. They really enjoyed it. But when they came into work, that wasn't what they got, so they went home to get their pleasure, so to speak. Nothing dirty about that at all. The point is, they went home to say, okay, I want to do real programming. I want to do something that's rewarding. You know, I want to write code that is elegant and spare, and the occasional well-turned architectural hack, as opposed to the total, complete, poorly structured architectural hack that is my day-to-day life. I don't want to live there. They were choosing a nice place to get away from. So, get away from the bad stuff. So there's this idea that it profoundly influences how people spend their time. And so we might as well start by looking at, from this perspective, what is it that makes a piece of code happen? And I like this quote from Chris Oldwood. It's a recent quote, because it challenges something, and it's a point that I often make. But he says it far more eloquently. Then, isn't a notebook screen a bit small? Me, no. If the code doesn't fit on it, it's too complicated. I frequently get people telling me that, oh, there's no problem with, you know, stupid names that are this long, because it's okay, I've got a really wide screen. And those lines that, you know, that run off to 160 characters or beyond, that's okay, because I've got 2 screens. And we're going to upgrade to IMAX next year. And the problem is, there's a profound misunderstanding. People think this is a technical problem. It's completely not a technical problem. It's a people problem. It turns out that it doesn't matter how you upgrade your technology, it turns out that you're still a human being. And it turns out that you can't actually, I'll make a point about this one in another talk that I'm doing this week, but it turns out you can't actually read much more than a very narrow set of things anyway. There is an idea here that vertical space and horizontal space are to both be valued, and it's not a question of screen resolution or working on terminals or whatever. It's actually a question of being a human being and being able to understand, can I decompose the problem to that level? Have I found an appropriate level at which I am describing it? Because somebody needs to read this, which I'm going to pull us right back to that parallel. Why it is that writers still offer us a better perspective on understanding programming than painters. Because when somebody programs, they are programming not merely to execute something, they are programming for someone else. There is an audience, and that audience may be that same person in 6 months' time, or it is somebody else. And therefore, you write in order to be read, not to be executed, although, you know, that has other implications. You write in order to be read. And therefore, the rules of reading are exactly the same. And if you write something that is hard to read, although there is that philosophy, it's hard to write, so it should be hard to read. We're not subscribing to that one here. There is that philosophy that you are trying to appeal to an audience, you're trying to convey meaning, and therefore, using up all the visual real estate is not actually a service to anybody except screen vendors. So there is this idea that we also need to question some of our habits, that we I find that a lot of programming is very ritualistic, and there's nothing wrong with that. We like our rituals because we are human. But there are certain rituals we do without necessarily questioning them. And there's this idea of cargo cult programming. Cargo cult programming is a style of computer programming characterized by the ritual inclusion of code or program structures that serve no real purpose. And you can actually see this a lot. I mean, the other phrase for cargo cult programming is enterprise programming. It's, and there's people spend a remarkable amount of effort achieving very little. And this includes in their code structures, their comments, and how they lay things out and pace things out. And there is a comfort that people may find in doing this, because that's why we do rituals, but at the same time you have to challenge yourself a little bit and go, well, hang on, from the reader's perspective, what am I actually offering them? And actually from an execution perspective, what am I offering? Does it actually do anything? It turns out in many of these cases you can just plough the stuff away. And there's some really interesting other aspects to this. Cargo cult programming can also refer to the results of applying a design pattern or coding style blindly without understanding the reasons behind that design principle. All too often, people look at particular practices and they look at the result of the practice and not the sensibility behind the practice. And they say, I'm using that technique just like that person over there did in their code. The problem is, although on the surface it kind of looks a bit the same, actually it turns out that underneath there is a missing sensibility, and you end up kind of going through the motions without actually getting anything working in the right way. Now, a parallel I often draw, sometimes talk about this in the context of agile development, but I think it actually generalises further, and I'm going to pick on my older boy, who would be embarrassed that I was saying this. He'd be embarrassed that I'm mentioning it at all because he's 13, and all 13-year-olds are inherently embarrassed by their parents. But when he was 5, he decided he was going to help my wife clear the table. And he did, and he saw what she was doing. And obviously, he's 5, he's a lot shorter. He saw what she was doing. And he repeated the action, because that's what humans do. That's one of the ways we learn. That's where this stuff comes from. We learn by imitation. Okay, this is not a bad thing. It has a few side effects every now and then. It gives us things like fashion and XML and stuff like that. But we ritually copy other people, and we sort of say, oh, that's interesting, okay, I'm going to try that practice. It's one of the ways that knowledge and practice spreads through the human race, and it's the basis of civilization, ultimately. But there is this very interesting idea that you need to sometimes understand the sensibility. Sometimes you copy what you think you see, but you don't see the whole picture because it's been cropped out. And from his point of view, what he could do is, what he was doing is, he could see my wife wiping crumbs off the table. So that's exactly what he did. What he missed was the fact that my wife had her other hand down here. It turns out that this makes this sensible. It makes it the practice. Otherwise, all you're doing is just pushing crumbs on the floor. What I've just done is describe every agile adoption ever, pretty much. Oh, I'm going to copy these practices. I've read them in a book. I've seen them on a blog. Somebody at a conference said something about them, and whoa, yep, we're doing it just like they were doing it. It's this. It's really subtle, but it's really important. And unfortunately, we see this ritualistically with a whole load of stuff. You know? They were just like, we're missing this, and this is the bit that makes the programmer a programmer. This is, in theory, the insight, the skill, and so on that goes together with that. But we need to challenge a number of the assumptions and default assumptions that we're often given, either by colleagues or by frameworks. Most of the time when I ask people about, I make a statement about a coding style, and people say, oh yeah, but we have to do that where we are. Oh, why do you have to do that? Oh, well, because the framework told us. Oh, so the framework is forcing you. Okay, so, it's like a dystopian novel, really. So we are living under the rule of this framework. And sometimes the IDE gets the blame as well. Well, this is what the IDE does. Did you know your IDE is configurable? Who knew? You mean we don't have to do this? Oh, wow. But again, most people go like, no, we have to do it because the IDE said so. Big brother and all the rest of it. So, it also speaks to another aspect that I think is certainly true. This is Anderson's law, Paul Anderson's science fiction author. I have yet to see any problem, however complicated, which, when you looked at it in the right way, did not become still more complicated. And this speaks to two aspects. There's two things that we can derive from this. One is that some problems turn out to be hard. They're turtles all the way down. They're fractal. The closer you go, the deeper they get, and the more detail there is. This is relevant because it tells you that the details are where you find the surprises. And this is important because when people do things like estimate, they offer an estimate, and their estimate is generally based on what they know. And somebody says, okay, now I want you to account for all the things that you don't know and roll those into your estimates. What surprises are you going to get? Well, if I knew what they were going to be, they wouldn't be a surprise, would they? And that's the problem. We have a very simple, unfortunate blind spot, which is actually hardwired, fairly deep in the wiring here, that if we do not know something, we assume it does not exist, rather than wander around with the possibility and the sense of uncertainty. You know what? That might be a problem. I don't know about that. You know, that might be a problem. Well, no, I don't know about that, therefore we can say that that's going to take 0 time. I've oversimplified it, but actually that's not too far off what the wiring is doing. You'll add some clever post-hoc reasoning to make it sound more plausible. But that matters because sometimes people, when they talk about code, they also say things, oh, don't worry about that, it's just a detail. You've probably heard it, you've probably said it. I know I probably said it, I've certainly heard it. Oh, that's just a detail. Pause, go back. Wait a minute, what is programming? Programming is the details. That is what it is. If it were not the details, then there would be no profession. There would be no skill in it. It turns out that when somebody says that's just the details, that's a minor detail. How do you know it's a minor detail? Have you been there? Did you come back? Or did you get lost? Because it turns out that the details are what makes a program. You know, if you've got a 1 million line system, that's 1 million lines of details. It turns out the details add up and they make, well, I don't know, what should we call it? Software. That's it. That's part of the job. So you cannot dismiss something as a detail. You need to include it. And the problem is you're not going to know this stuff. So there is, first of all, Anderson's law tells us that. But then the better interpretation is that it doesn't matter what you're doing, you can find complexity. You can fabricate complexity. Hey, look, there's a really easy task. You know what? I can make that much, much cleverer. To quote the late John Peel, I don't make stupid mistakes. Only very, very clever ones. That, unfortunately, is just like, oh, you know, I think we could do some reuse there. We could turn this into a framework. We can do this. So we go, oh, no, it's not enterprising enough. I see what you've done there. I see what you did. It was really simple. You took a customer, you put an order against them, and now the customer has an order. That's way, way too simple. I think we can make that. I think we can make that a little more sophisticated. I think we can really bring in some machinery to say the same thing. No, that looks like proper coding now. So there is an issue here that we can also able to fabricate combinations. So, going back to writer, Ernest Hemingway, let's pick on this one. Because sometimes we also mistake the big effort, because again, let's go back to the 1 million line systems. A lot of people tell me, oh, you know, I hear what you're saying, Kevlin, these all sound really good, but we work with big systems. Your little ideas are not going to apply to our big systems because we're special and big. Ernest Hemingway, eschew the monumental, shun the epic. All the guys who can paint great big pictures can paint great small ones. And that is a really important point. It turns out that one of the problems that we have is the fact that we think we're supposed to be doing big systems. We're going to have a big development. How are we going to make the big development? I don't know, let's make it big. Most of those systems that are 1 million lines don't need to be 1 million lines. I very rarely, I have encountered a 10 million line system that wanted to be 1 million lines. But most systems are 1 million lines. I mean, I could actually just generalize and say all systems are 1 million lines, and I think I'd only be 1 decimal point off. Don't need to be that big. They've ended up that big, but that's different. That's not they needed to be. They ended up being that way. And people are also very happy sometimes to say, well, it is this way, therefore it must be this way. But in many cases, we see, so for one company I visited 1 million lines of code in my system. I worked with these guys for a few weeks and eventually worked out that their system had comparable functionality to another team that I'd worked with in the same company. It didn't do the same thing, but it had comparable functionality to another team that had 100,000 lines of code. Now, that's quite a big difference, 1 million lines of code versus 100,000. You're sitting there going, oh, it's a factor of 10. That's not much. It's only one column in a decimal system. No, it's huge. A factor of 10 is enormous. It's a really big difference from a cognitive perspective. And why does the cognitive perspective matter? Because it turns out that programs are human. It turns out that it's what you can fit in your head and what you can fit through your eyes. Can you reason about it easily, comfortably, confidently, and all the rest of it? Or is it a bit of a battle? Or is it a lot of a battle? In fact, it might even be a war. 1 million lines of code, I'm going to say that's a war. At another company, there was a 140,000 line system that was, I did a re-estimate. I worked out they could do it in about 5,000 lines in the same programming language with the same technology. This wasn't even a technology switch. I don't know about you, but there's quite a big difference between 5,000 and 140,000. 140,000 is how you create your own work. So we end up with this, because surely everybody thinks, you know what? We're logical. This George Bull, who gave his name to a data type, very generous, and classic Victorian gentleman, in this case, and he did not invent logic, but he formalised propositional calculus as what we now call Boolean logic. And he was influenced and reflected the times in which he lived, Victorian era. And so certainly the book title is very much of that era. You know, an investigation of the laws of thought on which are founded the mathematical theories of logic and probabilities. These days it would be laws of thought. As you can see, that's how it is. Or logic distilled, something like that. Okay, we choose a much punchier title. But notice that how it is generally referred on this book cover is the laws of thought. I refer to it like that. Oh yeah, George Bull, the laws of thought. Because there was this idea that perhaps human beings are logical. The Victorian idea is that actually human beings are logical. That everything has a place and there's a mechanical order to the universe. Human beings are intrinsically logical. But somehow it is society's ills and the weakness of civilization that we are not able to nurture the logic, and we confound people with illogic, so we must represent this kind of Platonic ideal of logic. That's a nice idea. It's also not true. Let's bring this into the 21st century. A rather nice book by Gary Marcus, Klooge, published in 2008. Klooge, a solution that is clumsy or inelegant yet surprisingly effective. Yes, software developers know this word, they know its meaning. But what he's referring to is not code. He is referring to what goes on in here. He's saying, look, are human beings noble in reason and infinite in faculty, as William Shakespeare famously wrote? Perfect in God's image, as some biblical scholars have asserted? Hardly. It turns out you're not logical. You're profoundly illogical. It turns out human beings are not rational. It turns out that logic is a thing that you learn. It is a thing that you are schooled in. Boolean logic is actually quite foreign to human beings. How do we know this? Well, if you've got kids, you'll know this. Okay? You suddenly look at this, it's like, wow, okay, how do you get that reasoning? Trying to reason with them, that's a waste of time. Assert parental authority, okay? It's just a case of, well, logically, this and that, and there's a logical implication. You get like little 4-year-olds sitting there like that, what's the logical implication? Yeah, or just crying. This parenting advice is brought to you for free. No, I've never tried that on the kids. Because the logic just doesn't work. Because you know what? It doesn't work with adults either. It's just we're really clever at hiding the fact that we're illogical. We spent years coming up with post hoc reasoning that sounds plausible. But actually, underneath it all, it's still the same raw kids. We've just got clever ways of hiding it. And occasionally, there's a little crack in the veneer, because you think, well, hang on, look, I am programmer, I am logic. I am the embodiment of logic, because surely I manipulate Boolean algebra all day long. I'm writing conditions and I'm doing things on them, so surely I am better informed than most of the human race. Perhaps, but you know what? It's a veneer. That means it cracks occasionally. And occasionally you make a stupid mistake. If it were natural, you would not make this mistake. You're sitting there and you're going, oh, I meant to put an and, not an or. Or there should be a not there. How did I miss the not? And these kind of things, and you pass over them, you forget about them. But the very fact that you're doing it shows you that it is not, it's not an innate thing. It turns out it's a learned thing, and every now and then it kind of breaks down a little bit. Okay? So we're not as logical as we'd like to believe. We might have a head start on some members of the population, but still not as logical as we'd like to believe. Although that said, I'm going to go back to writers. They're not very logical either. So we do have something in common. And we can see various things. How does this and these weaknesses of rationality affect us? It's a nice piece from New Scientist, actually, looking back at the economic crisis. Well, I'd like to say the economic crisis of 2007 and 2008, but it also turns out to be 2009, 2010, 2000, etc. But they look at this from a particular perspective. And it's a perspective of being human. They're looking at economics, but we're going to look at code. I think that the three of the best documented tenets of economic psychology can help explain why we collectively took on the loans that eventually proved were so unwise. The first is materialism, the second is money. Finally, we have the most spectacular deviation from rationality, the massive myopia with which we approach the choices between good things that will arrive at different points in the future. Humans are quite hopeless at such intertemporal choice, consistently choosing to take small benefits sooner rather than large benefits later. This informs the economy, but it also informs our practices and how we work with code. It takes sometimes a will of, a real sort of major effort, real will to say, you know what, that piece of code is messy, I should not leave it messy, I should not check it in as messy, we should not tolerate the messiness. Because in the long run, this is probably not going to work out well. Alternatively, we just short circuit and say, it's going to work out well in the present, it saves me 5 minutes not doing that. It saves me 5 hours not doing that. If nothing else, learn that there's a really cool phrase called intertemporal choice that you can use against your colleagues. Okay. Yeah, I think we need to take an alternative intertemporal choice here. They sound really cool, really smart. Use it, okay? But why does this make a difference? It makes a difference for a lot of reasons. It's not just a question of writing code, it's a question of things like testing. When you test, how you test. Intertemporal choice. Well, I can save a lot of time at this point by not testing. I save a few hours here and there. But the problem is we're really bad, not just at intertemporal choice, but at intertemporal evaluation. In 6 months' time, when something goes wrong, do you think, oh, you know what, that Tuesday when I went home half an hour earlier because I decided not to write that one test case, if I'd written that one test case, this would never have happened the last 2 weeks that I've spent trying to find this bug. Okay? We don't connect these things. We're very bad at cause and effect. I mean, we're horrifically bad at cause and effect. If there's a cause and sometime later there is an effect, we don't actually look at that as causal. If there are two things that are completely unrelated, we assume, and they happen at the same time, we assume cause and effect. This gives us things like politics and homeopathy. So, the point here is that we need to be very careful of this. And again, back to the economists, there is this idea, again I'll quote New Scientist, although individuals in some markets display it, economists dislike it on the grounds that it is irrational. What is it? It is hyperbolic discounting. That's another phrase you can use. The hyperbolic discounting effect. That's great. What the hell is that? Well, the way that economists like to think about things is that everything undergoes an exponential discounting effect. In other words, you've got a preference for certain things now, and over time, the value of things decays really nicely like that. That's nice, the equations go out nice as well. The problem is hyperbolic discounting sharply accentuates. What it basically says, to translate it differently, is that you have a really strong preference for living in the present. You will value decisions that reward you now far more than decisions that may reward you a bit in the future. A lot more. Again, this informs our practices. It informs the way that people respond to deadlines. It informs the perceived pressure that may come from other parts of the business where people say, oh yeah, but they need this feature, so we've got to put it in, so we're going to make a real mess, unfortunately, in putting it in. But that's okay, because we'll meet the deadline. You know, if that were the only deadline in the world, that would be fine. The problem is, guess what comes after that deadline? It's software development. Of course there's going to be another deadline. Software is not dead. This actually is like that. There is a beautiful quote. A painting is never finished. It is only ever abandoned. This applies to software. Software is not done until nobody is prepared to fund it anymore. That's when it's done. When people think, oh, I'm done. No, you're not. Software is dead when your backlog is empty. Okay, that's it. When there is nothing more to do, when people have not got any more features they want to put in, when they have not got any more money to fund any features, in either of these conditions, the software system is now dead and done, and you can say we finish it. But the problem is that that's not a project, it's a product. And our thinking is slightly skewed. And therefore, if we get deadline-centric with short-termism, and in fact, I've actually started doing this with a couple of people, sort of talking about the idea that, particularly one company I've visited over many years, and I've seen how they've responded to some of their deadlines and their changes. I actually asked them, I said, do you remember that year when you kind of spent all that time not implementing something because you were worried that you might implement the wrong thing? And then you ended up implementing something really badly because you ran out of time to implement anything that was right. And you did it to save time. How much time do you think you saved? And I tried it with another group. How much time do you think you saved? If you've had a development for over, something like 10 years, you have plenty of time to look back and say, you know all those shortcut decisions, how much time did we actually save by doing them? And it turns out that it doesn't look good. This is because, unfortunately, this idea of strong preference for getting something today rather than tomorrow. Only a weak preference for getting it on day 100 rather than day 101, yet when day 100 arrives, they will strongly prefer to get the resource immediately. In other words, you'd rather have it now, whatever the value of now is. I would like the reward now. I don't want to have to spend time on something. Now, I'm exaggerating a little bit, but there is this idea that there's a certain amount of wiring that is supporting this. So this tells us that we are human. It also tells us that we have to be very careful and balance the ambitions and visions that we've got so that they are actually realistic. It's a nice piece of advice from a writer, Chuck Wendy. 25 things writers should stop doing. And one of them is stop over-promising and overshooting. I really like this one, because he makes the point, you know, we want to do everything all at once. Grand plans, sweeping gestures, epic 23-book fantasy cycles. Don't overreach. Concentrate on what you can complete. Temper risk with reality. This is really important, because we do the same thing when we're imagining a large system. The customer wants this, they want this, oh, we're going to build a whole new platform. Okay, yeah. 23-book fantasy cycle. It's going to be there. It's going to be the best thing ever. It's just, yeah. And I had a really interesting experience a few years ago when my older boy was into Warhammer, wargaming, and I used to, because he was under 10 at that point, and for legal reasons, you know, it turns out Games Workshop is not a crash. If the kids are under 10, they have to have a parent or guardian, and a responsible adult. Well, actually, no, an adult. I don't qualify as responsible. They have to have an adult accompanying them. So, actually, the Games Workshop in Bristol, where I live, the one in the centre bench, you have some chairs. There's the parents' chairs. You kind of go there, and it's a case of kids are off doing the wargaming, painting little figures, and playing things out. And I got talking to one of the guys there. I happened to be taking I took a story of mine along. I sort of printed out a story, and you know, old school, I used paper. And so I printed it out. I had a red pen. There's a shop near me that actually stocks red pens for teachers and the like. It's great, so you can write in red. I ignored the fact that I'm colourblind, because it's the cool fact of having a red pen going in and work. It's just like, okay, what can I adjust? And he asked me about it. We got talking, and I said, oh yeah, I do a bit of writing and stuff. And he said, oh yeah, I've got this idea for I've been writing, it's going to be a novel or screenplay, and I've been working on it for 1.5 years, and it's just like, it's big, it's kind of like, and there's a sequel, and all the rest of it. Oh wow, fantastic! And so, how much have you written? Oh, I haven't written anything yet. It's like, oh okay, you know what? He's not alone. And we also get this. There's a paralysis that sometimes occurs, either within organisations or within development teams, or within individual developers when they're trying to do a project. We're paralysed by the possibility that it might not be perfect. But we have such a perfect, large vision, we're unable to scale it down. But Neil Gaiman, one of my favourite writers, you have to finish things. That's what you learn from. You learn by finishing things. It turns out most writers are rubbish. This is not news. Most of everything is rubbish. This is Sturgeon's law. 90% of everything is crap. And so, how do you get better at stuff? Sometimes people assume that there's an innate ability. You are born to do this. Well, trust me, nobody was born to code. Code is a complete human construct. There's nothing in our genetic makeup that suggests we can do it. It turns out that we might have predispositions for certain styles of thinking, but at the same time, you're still not born to code. You have to practice. You can be very intelligent, but that doesn't mean you can code. Okay? It turns out you have to practice. You have to learn by actually doing it. It turns out that if you want to learn how to develop, then you have to do it. If you want to learn what a large system looks like, then you have to actually try building it, instead of spending 2 years pontificating about what it might be or what it might do. So this is the classic paralysis you get in large organisations with large projects. At the end of the year, end of 1 year, you're looking at it going like, okay, what have you guys done? Well, we've written a lot of documents, we've had a lot of meetings, and you know, all the rest of it, but there's still no system. Have anybody written any code? Well, a couple of people, but we don't talk to them. It's like, well, no, because the point is the code is real. That's what you learn from. You learn by finishing. Because it is in the detail. A software system does not exist in the abstract. Although it's an abstract construct, it does not exist in the abstract of conversation. It exists by actually being written. And so therefore you have to learn about it, which is why breaking things up into smaller things. Whatever paradigm or style or approach that you choose, whether, you know, the idea of an increment, the idea of, well, let's just take a slice of something and implement it, and we'll find out, because, you know, either we're going to learn that we're really good at it and we can do the next increment, or we're going to learn very quickly that it sucks. And again, that's a good thing, because it's nice we didn't try the whole system. It's good to get, if you're going to get feedback, it's nice to have it a little bit earlier, especially feedback that's negative. So, there is this kind of idea that we end up being very poor at planning our time, and our ambition, and organising. So you end up with this very, very curious thing. And it's kind of exemplified by a conversation that I caught a fragment of. About 2 years ago, I was going over the bridge, the Blade of Light, over towards the St Paul's from the Tate Modern. It was in the morning, and I overheard one person saying to another, you know, oh, so-and-so said to me, well, what is it that you're doing? Because you're in a meeting right now, and I was doing something else, and da-da-da, and I said, haven't you heard of multitasking? And da-da-da-da, and the guy was agreeing with her, and was just like, yeah, we have all multitask now. I've got some bad news. You suck at multitasking. You, me, everyone else. Actually, there's a very small proportion of the population that are supertaskers and can actually multitask. And when you give them more work, they actually do it more effectively multitasking. And you're probably thinking to yourself, if you thought that you could multitask, you're probably thinking, that's me. I'd just like to point out that in this auditorium, there may be one of you. Maybe. Yeah? And, statistically speaking, there's not a lot of supertaskers out there. Most of us are just ordinary human beings. Yeah? You are not expert. Okay? Yeah, you do not have the mutant gene. In all probability, you do not have the mutant gene. This wonderful observation. Social scientists have long assumed that it's impossible to process more than one string of information at a time. The brain just can't do it. But many researchers have guessed that people who appear to multitask must have superb control over what they think about and what they pay attention to. In other words, executive control. So Clifford Nass and his colleagues set out to learn what gives multitaskers their edge. What is their gift? Because there are people who go out and say, yeah, I'm multitasking, it's my thing. Well, if that's your thing, then clearly it should be subject to observation. And we should be able to find evidence for it. So let's go and find out. We kept looking for what they're better at, and we didn't do it. It turns out, one of the things that we're also really good at is fooling ourselves. It turns out that, to quote Richard Feynman, science is the best way we have learned about how not to fool ourselves. Okay? Here we have the answer. It turns out, except for a very, very small proportion of supertaskers, it turns out that what you are very good at is maintaining an illusion about yourself and your skills. And this is unfortunate, because a lot of the way that we've structured our time, because we say we're going to finish things at various points, because we say we're doing these grand things, because we're busy yak-shaving something whilst we're focused on another task, although it's fun, it doesn't necessarily, you know, acknowledge that it's fun, but it doesn't necessarily mean that it's effective or that you're making good use of your time. We are very poor at this. People who are regularly bombarded with several streams of information do not pay attention, control their memory, or switch from one job to another, as well as those who prefer to complete one task at a time. The bad news is you're basically single core, which is disappointing. Oh, sure, there's background tasks. I mean, the whole breathing and heartbeat thing, that's been outsourced. That runs on a separate board, okay? That's nothing to do with this. And there are certain tasks that you can do if they're profoundly independent. And there's this beautiful quote in the Keynote Manifesto. Okay, you think you can multitask? Right, fine. Try writing a book and reading one at the same time. Okay? Some people go, well, yeah, I'm reading something at the moment, I'm writing. No, at the same time. At the same time, there's only one definition of at the same time. Simultaneous. Not, oh yeah, I was reading it this morning and then I started writing something. That's at different times. But you don't need Einsteinian relativity to work out the time relationships. Okay, those are different. You put something down and start something else, that's different times. But simultaneous, turns out we're not very good at that. So this is interesting, because here's a point that Paul Graham makes that I do agree with very strongly. He goes elaborate on the maker schedule at that point. He talks about the way that people organise their time and therefore how they value their time. I think this is interesting. One reason programmers dislike meetings so much is they're on a different type of schedule from other people. Meetings cost them more because there's a context switch. So, for example, I used to work for an organisation where, let's just, for example, meetings between departments and also interviews, doing interviews. And somebody else will organise a meeting for you. They'll put it in your calendar. And they will, particularly when doing a round of interviews, you end up, they sort of load balance it. Oh, we've got 5 interviews to do this week, we'll spread them out so that Kevlin doesn't end up doing all the interviews on one day. Monday, Tuesday, it's nicely evenly balanced. Actually, that puts an immense amount of pressure on you, because it's causing you to be interrupted at one point. You can't really get into the zone on something, because suddenly, I've got to remember that I've got to be at an interview in a bit, and then I need to prepare for that. And that's always in your mind, that's always holding you back. And there's a context switch there. It turns out that it disrupts the nature of your work. So for someone on the maker schedule, having a meeting is like throwing an exception. It doesn't merely cause you to switch from one task to another, it changes the mode in which you work. Highly interrupted. You are losing an awful lot of what could be progress. Now that might suggest, oh yeah, maybe putting all of your meetings in one day is a really good idea. You know, that would be really cool if it were true and that simple. But it's not, because there's another thing, because we're human. There's a thing called decision fatigue. Again, this has been observed. Decision fatigue helps explain why ordinarily sensible people get angry at colleagues and families, splurge on clothes, buy junk food at the supermarket, and can't resist the dealer's offer to rust-proof their new car. No matter how rational and high-minded you try to be, you can't make decision after decision without paying a biological price. The issue here is not whether or not you are overall rational, but whether your rationality or irrationality is actually constant through the day. And guess what? It's not. And I'm not talking about alcohol here, which obviously has a profound effect. I'm also not talking about, you know, if you're a new parent, I'm also not talking about the profound sleeplessness that you may actually have. Okay? Clearly lack of sleep, that's going to affect your ability to reason. No, this is actually much simpler. More choices you make, the harder each one becomes for your brain. Eventually it looks for shortcuts in one of 2 different ways. It looks for shortcuts. What's happening is that there is a cost. There is a biological cost to doing decision after decision after decision. When you're programming, you're making a lot of decisions, but if you're in the flow, then that's kind of just about as sustainable. You know when you have reached a point where you're not actually able to reason about something anymore. You start looking at pictures of cats. And this is one of those kind of profound observations, that a room full of programmers developing software is indistinguishable from a room full of people looking at pictures of cats on the internet. It's not like it is in the movies where programming is apparently really exciting and you get the code projected on your face. I mean, I'd kill for that stuff, that's great. But sadly, you go and look at a room full of successful developers and it's just like, okay, that was not very exciting. You know, there's something missing that's just not as dramatic as we hoped for. So how do we look for, so decision after decision, it turns out you need to take a break. You can't sustain a particular level. So maybe you do schedule everything into one day, but you have to put breaks in. So the ways that we look for shortcuts, one way is to be reckless, to act impulsively instead of expending the energy to first think through the consequences. The other shortcut is the ultimate energy saver, do nothing. Now, the project I was on a few years ago, I remember that there was always this really long meeting on a Friday. Really, really long meeting on a Friday. The project was in crisis, we always had these long meetings on a Friday. whose only purpose was to be a long meeting on a Friday. And it would just go on and on and on, and we'd make these decisions, and you could tell people were kind of making worse and worse decisions as the day went on. And it's just like part of you wants to go home, but there's also the idea it's been a long week, and you're not able to sustain this. So you start making stupid decisions. What about we try that? Yeah, it sounds great. And if the only good thing about it being Friday is that Monday you could come in and look at that decision and go, no, that's terrible. What on earth are we thinking? But there's the other thing, which is the other option, and this is one of the places where this first turned up, this research on decision fatigue, is that you make very simple conservative choices. This decision turned up, this observation turned up in the courts in Israel, that a number of prisoners observed judges hearing the cases of prisoners on parole, or looking for parole. Okay, so they hear these parole cases. And one of the things that is interesting and significant is that it was Israel, which is clearly a politically tense environment. And the prisoners were a mix of Israelis and Palestinians. And you'd think that perhaps the bias of the judge would be reflected in who they granted parole. You know what they observed? They did observe a bias, but it turned out to be nothing to do with whether you were Israeli or Palestinian. It completely depended on how recently the judge had had a break. If you plotted it through the day, it turns out that the more decisions the judges made without a break, the more conservative they become. And by conservative, I'm not talking a political aspect, I'm talking about, well, you know, let's just leave the prisoner where they are in prison, rather than take the risky option, or the considered option, which may be granting them parole. It turns out that they were taking the no decision more and more often. It turns out you end up making no decisions. So it turns out, have a break with lots of glucose, and that will make a difference. But this affects you. This is the whole point. When you're going to organise your schedule, trying to pack anything into one go is a high-risk option and leads to the possibility of making poor decisions, either because those decisions will be non-decisions, in other words, you won't really have decided anything, or because they will be highly unreliable decisions. Which is one of the reasons we develop in teams. Problem is that we have this idea, there's this idea of the wisdom of crowds, and we think, oh, that's great, the wisdom of crowds, so that makes us sound really smart. Yeah, well, the problem is we also have a downside to this. There is the idea of groupthink, okay? The idea of getting a group of people together, and it turns out that they actually can act dumber than the individuals within the group. In this country, we call it Parliament. It turns out that the wisdom of crowds is subject to some very specific, if you want to get a group of people to be smarter, then you have to have a few conditions. Now, James Surowiecki, in his 2003 book, highlighted what these conditions were. Diversity of opinion. You need differences within the group. So a friend of mine, he ran a startup, which became shut down, unfortunately, and he ran a startup, and unfortunately he got to the habit of hiring people who were just like him and the other founder. And they actually got rid of somebody, not because their work was bad, but because they just weren't on message. And they didn't think the same way. It turns out that if you all think the same way, then it doesn't matter how smart you are, you're probably going to be wrong at some point, statistically. And you're not going to have any breaks and checks and balances in the system for that. Independence. You need to watch out for groupthink. We are often influenced by other people. Decentralization. You need to be aggregating your information from different sources, but importantly, you need to aggregate this together. This is the interesting thing, is there's no good having everybody being smart and individual if you don't have a way of bringing this together to get a collective style of thinking. And this is indeed one of the cases that we suffer from in development processes, is that people are individually sometimes making some great discoveries, but there's no mechanism for them to feed back. You know what, we shouldn't be testing like this, we should be testing like that. We should not pursue that piece of the architecture, or that style of architecture in that part of the code, because that's not an effective approach. This coding style that we've got, well, I've tried this new approach, and it's much tidier and cleaner and so on, and it takes advantage of a few new language features, but it turns out it's not just nice because it's new, it turns out it's nice because it's really effective. And individually they know that, but how do we get that knowledge out there? So this idea of aggregation, how do we bring that together? And this turns out to be a people thing. Indeed, at one level, we can actually regard every large software development project, and by large I mean anything more than one person, any software development effort is a collective effort. It's a kind of a hive mind in that sense, but and therefore the code base is an aggregation of your collective wisdom. And sometimes we see that it's kind of a bit, well, it's a bit muddy here and there. And it's a bit isolated. There's good ideas over there, but then there's a track of bad ideas, and there's another good idea over here. Rather than being a genuinely sort of best of all possible thoughts. There's also another condition, it turns out, not covered by James Surowiecki's book, covered in this research here. There's a little correlation between a group's collective intelligence and the IQs of its individual members. This piece of research is kind of interesting because what they discovered was if a group includes more women, its collective intelligence rises. I'm going to say you could be smarter. This piece of research 4 years ago, and we followed it up, is kind of interesting because this was not the effect they set out to find. But they had enough controls that this was the effect that they understood that this is what they'd observed. Very, very interesting. You can hypothesize as to why this may be the case. But I have to say, ever since running that, whenever I run a workshop, I always try and make sure that if there are enough, I will always make sure that each group in a workshop, when I split up, when I divide up to groups, I make sure that each group has at least one woman, because I don't want to give anybody an unfair advantage. And it does actually make a difference, bizarrely enough. So there is this idea. It's not that bizarre. It is actually a real effect. Turns out that this is actually one of those elements of diversity that James Surowiecki was talking about. So this also speaks to something else about how we consider the role of the program. It is often considered, these days we tend to consider it as unfortunately a very male role. You see this in a lot of advertising, but historically this is not the case. Programs were historically women. And there's a kind of a sense here, it's not just a question of balance in society. It actually turns out that there's a cognitive cost, and if you want to do software development, collectively you need to be smart. Everything that you can do to be smarter is necessarily a good thing. So, at this point, we can kind of realise that that what we're looking at is a question of organisation and scale. And typing is not the bottleneck. This is a phrase, it's a phrase that became a bit of a meme a couple of years ago, but I coined it, it turns out, a few years ago, back in the 20th century. Because I kept observing that many of the efforts and many of the things that people were doing in terms of productivity tools, they seemed to be solving the problem of typing. I would talk to vendors about their modelling tools and, you know, the code generation they had, and they always focused on this as if, well, look, we've generated 50,000 lines of code from this model. And you're looking at it and you say, well, okay, but was typing the problem that we were solving? Because if it is, you've solved it. But I remember looking at one of the generated code sets for one particular vendor and saying, well, look, you're claiming that you've generated 50,000 lines of code, and isn't that great? Because it would take developers a long time to do 50,000 lines of code. But I'm looking at your code, and I think a good developer could do it in 5,000. So, what are you doing with the other 45,000? This is just noise. You've just embodied cargo cult programming and generated it badly. But there is this idea that a lot of effort has been spent trying to focus on the typing issue. Oh, sure, you want things to be at your fingertips so that you have a continuous flow. That's not to do with the speed of anything, that's to do with the speed of this. You want to match things. This is why shortcuts and things like that are very helpful. That's to do with matching this flow. But overall, in software development, typing is not the bottleneck. And Sebastian Hamid came up with this lovely graphic a couple of years ago, so I kind of use that one now. Typing is not the bottleneck. So many efforts at what should we do with software development are about, let's deal with the typing problem. It's like, no, it's the thinking and understanding and working as a group of people problem that actually turns out to be the real challenge. And people say, yeah, but that's really hard. We can solve the typing problem. Yeah, but we don't have a typing problem. It's the thinking and the people and understanding problem that's the real one. This is not a problem that needs to be solved, and indeed most of the attempts at trying to solve this problem end up with collateral damage. And unfortunately, it also informs how people scale teams up. We need more typists. No, you need a few more programmers, but you don't need lots more typists. Maybe a couple more programmers who have different backgrounds to the ones than your current programmers, who may offer a different perspective. It turns out that if you're stuck, then doing more of the same thing does not get you out. And unfortunately, the way that most teams are scaled up is based on the idea of, well, you know, we're not getting it. Tell you what, let's double the size of the team. And put the other new team in another country. Yep, that should really help. It turns out that's not the problem that you needed to solve, and that's certainly not a solution to that problem. So, this kind of puts us right back. So I'm going to look at this from another perspective and reach a conclusion that is the observation of another writer, Susan Sontag. Our task is not to find the maximum amount of content in a work of art, or bridge the writing and programming divide. Our task is to cut back content so that we can see the thing at all. If I'm going to say there is one thing that we can learn from the arts that may well parallel what we find in code and the act of producing code that leads to software, it is this idea that we have fallen in love with things that are large, that are at scale. We've fallen in love with things that are noisy and difficult. And it turns out that we need to be looking for things that are a little more elegant, a little more of a reflection of the actual intelligence of the individuals and an honest reflection of the intelligence of a team. And occasionally accommodate a well-turned architectural hack, but you're not going to see it if it's lost. Thank you very much.